Hi everyone, let's start solving today's lead code daily challenge question 1372, longest zigzag path in a binary tree. So this question asked in Amazon 6 times. Okay, so let's try to understand the question first. So you are given the root of a binary tree. A zigzag path for a binary tree is defined as follow. Choose any node in the binary tree and a direction. Either I can choose right direction, either I can choose left direction. If the current direction is right, move to the right child of the current node, otherwise move to the left child. Okay, so I can make any of the decision. I can move either to the right child, either I can move either to the left child of the current node. So change the direction from right to left and or from left to right. Okay, I have to change the direction. Repeat the second and third step until you cannot move in the tree. Zigzag length is defined as a number of nodes visited minus 1. A single node has a length of 0. Okay, so return the longest zigzag path contained in the tree. Okay, so let's try to see some observations here. So if I am currently standing at the root node, so it doesn't matter if I am coming from left direction or right direction at the root node. So let's suppose you are currently standing here at the root node. So from here, based on the previous direction, I can make some conclusion on the count, but it does not dependent on which direction I have to move. I have to calculate on both the direction. On the left, I have to traverse in the left direction as well as in the right direction. Okay, so if I take this example here, there is no left child, but let's assume, okay, there is a node exists, so I have to go in that direction. Okay, so if I am going, so let's take one variable count. Okay, so what are the observations here? If I am coming, if my previous move was left and I am coming in the right direction, in that case I can increment my count. Okay, but in the case if my previous move was right and I'm going again in the right direction, in that case do I have to increment my count? No, in that case it is going to be a new initialization of my count. So in that case, if I am going from the right direction, coming from the right direction, in that case my count will be 1 only. Now, so here if I suppose I came from left, my previous move was left when I visited the root node. So as I said, it does not matter on the root node from which direction you came from. So I came to right direction. Okay, so let's suppose let's take the previous, sorry, so let's check the previous move was left only. Okay, so in that case the previous count was 0. Now I am coming in the right direction, so I have to increment the count. Okay, now I reached here and my previous move was left, but now I came to this node via right direction. Now if I go in the left direction, I can increment my count. So here the count was 1, and if I visit this node, my count again will increment by 1. So at this stage my count will become 2. But now as my previous direction was right, I am coming again inside the right direction. I cannot increment my count because it will be a new beginning of the tree traversal. So at that case count will be of 1 only. So here I need to reset my count to 1 only and mark my previous move as, so I from which direction I came now, I came to right direction, so my previous move was right here. Okay, now from this node I have to make two decisions. Either I can go left, either I can go left, either I can go right. So if I come to left, okay, and my previous move was right, and then currently I am at left child, so I have to increment my count. So here count will be incremented by 1, and at this stage count will be of 2. Now here my previous direction was right and I started traversing in the right direction, so the previous move direction and the current direction is same, So in that case I have to reset my count value to 1 only. Okay, now let's say now here my previous move was right and here my previous move was left only. Okay, now I cannot go in the left direction because there is no edge present, but I can go in the right direction, and as I compared, my previous move was left and I am currently came inside in the right edge. So here I need to increment my count by 1. So I will increment by count by 1. So previous count was 2. So 2 plus 1 is equal to 3. Okay. And here the previous direction, from which direction I came to this node. So from the left. Okay. Previous direction was left. I cannot go in the left direction, but yeah, I can move to the right direction. So here here I came via right direction only. So if I visited this direction, I have to reset my count variable to 1 only, and at every step I will be managing one variable, let's say the max length or answer. So at every step I will be comparing with the max length or answer. Okay, so here the 3 will be the answer. So for this particular example, my max length is 3. Let's do one more dry run. Okay, so at root node it doesn't matter where you came from, either left, either right. So for simplicity I am picking left. Okay, I can go in two directions, either left, either right. If my previous move was left, and let me maintain a count variable as well 0. If my previous move was left and I came in left direction, so I have to reset my count to 1. But here if my previous move was left and I came in the right direction, I can increment my count by previous count. So count plus 1, which will be 1 only. And let me maintain a max length, which is nothing. I compare it, previously it was 0, now it will become 1, and here the count is 1 only. Now here I reached via which direction? From left direction only, and from here I reached via right direction. Okay, now I cannot visit left because there is no edge present. Now my previous move was left and I came in the right direction, so I have to use this count variable which is previously I computed, and I need to increment it. Okay, so count will increment by 1 and now the count will become 2. I will compare it with the max length, it will become 2. Okay, here it will stop because I do not have any place to go. Okay, so and here from which move I came to this node, from right direction. Okay, now I can go in two directions, left as well as right. So if my previous move was right and I am going in the left direction, I can increment my count plus 1. Previous count was 2, so 2 plus 1 is 3. I can compare it with max length will become 3. Now from which node, from which move I came to this node? From left direction, so I can mark it as left. Now if I try to compute this particular node, so from the previous move was right only and here I visited in the right direction, so I have to reset my count as 1 only. So at this particular stage I have to reset my count variable. Now here, so my previous move was left and here I can go in two different directions, left as well as right, but there is no edge present on left, so I cannot go there, but I can go in the right direction. As my previous move was left and I came in the right direction, so I can use the previous count, which is this, which is stored at this particular node. I can use this particular count and increment by 1. So 3 plus 1 is equal to 4, and here I can compare it with my max length, and here the maximum answer will be nothing but the 4 only for this particular test case. So I hope like this diagram will help you a lot, and let me give you a walkthrough of code as well. So what we discussed about, I tried to implement the same thing. This is nothing the answer which I return as part of longest zigzag method. This is nothing but the max length which we discussed about in the discussion. So I am maintaining a count. So as I said, if I am standing at the particular root node, it doesn't matter from which direction I came from. So initially I set it my previous move as left only. uh, it doesn't matter in case of root node. So I implemented DFS. So where I went to root, I have to send the root. I have to maintain count as well as my previous move, because at each uh, iteration I need to check what is my previous move. That's why I'm sending previous move here. Okay, this is the base case. Okay, at every step I am comparing with the max length and count. Okay, so if my previous move was left, like current node, like suppose this is the current node, I am saying this is my current node. So if I reached current node via which previous move? Left. My previous move to reach this particular node was left. So I can choose two directions. Root dot left, I can go to root dot left. Either I can go to root dot right. Either I can traverse left child or either right child. But if my previous move was left and I am going into left direction, I have to reset my count. And if my previous move was left and I am going in the right direction, I had to increment my count. Okay, else part, if my previous move was right, okay, previous move was right. So if my previous move was right, I'm going to traverse the left child of that particular current node. I have to increment my count by 1, and I will set the previous move as left. And if my previous move was right and I'm going in the right direction only, so I have to reset my count to 1. Okay, and I will set my previous move as right only. So in this case, the time complexity max, I will be I am accessing all the nodes only one time, so it will be nothing but order of n, the time complexity, and the space complexity will be nothing but the height of the tree. Yeah, so that's a complete solution of this particular problem. And if this video helped you, please like this video and subscribe to my channel. Thank you so much.